Okay, so what are the two things that we talked about yesterday that we are on the lookout for in terms of domain restrictions? Remember, you're the bouncer outside club domain, and we can't let everybody in. We have to guard against who or what? I'll give you a hint. What's that? What, Laddie? Yeah, those two, right? We can't divide by 0. So anytime you have a denominator with a variable or a hidden denominator, which would be something to the what power? What type of exponent gives you fraction? Negative, right? So sometimes I'll try to sneak those in, right? You'll have guys that try to sneak in the club with fake IDs. So you see a variable in a denominator or in something to a negative power, there might be values of x that makes it 0. So we want to find them, toss them out of the domain. And the other one is we can only take square roots, fourth roots of non-negative numbers. So if you ever see a square root or a fourth root or a sneaky one raised to what power? Radicals are what type of exponents? Not negatives, fractional, right? Like 1/2, 1/4, something like that. And you have variables in there. You need to make sure that those are not negative, okay? So let's take a look then at example 4. That's what we're going to be doing. We're going to practice them in isolation, and then we're going to combine our results. Find the domain of each of the following. We're going to state our answer and set our interval notation. All right, so we got the function. His name is Frederick, but F is short for Frederick, so his name is F. X is the independent variable. We have a rational function. It's a polynomial over polynomial. First of all, do you see any square roots or fourth roots or fractional exponents? I don't see any either. Good. So we clear that bar. Do we see any denominators with variables? Yes, we do. Yes, we do. We have a quadratic. So remember, that means there could be up to 2 values of x that give us division by 0. We want to find them and kick them out if they exist. So here's what we're going to do. Anytime you have a denominator with a variable, this is your plan of attack. You're going to take the entire denominator, the entire thing, and you're going to say it's not equal to 0. Okay? That's what you're going to do. Because we're trying to avoid a single number, namely 0, and we know that now there could be at most 2 of them, we're going to find the values that don't work. And therefore, everything else in the real number line will work. Okay, so that's your plan of attack. So here's what you're going to do. Get in the habit of labeling your work, especially later on where we're going to have both cases in one problem. So I'm just going to write denominator. This is basically me saying I'm doing the work for the denominator right here. Now underneath there, I'm going to put x squared plus x minus 6 cannot equal 0. And so on a quiz tomorrow or something, that would earn a check right there. That's your setup, okay? You're indicating to me or communicating to me what it is you're doing. Now, it's a non-equation or an unequation. I don't know what you want to call it, but you can solve it as if it were an equation, okay? So how would we solve something like that if it were equal to 0? We'd factor it, right? So that would be your next step. Factors of negative 6, that adds to positive 1. That's going to be an x plus 3 and x minus 2. Now, here's another thing that's a common mistake. You got to keep it equal or not equal to 0 as you work down, because that could cost you a check if you don't keep it as an equation all the way down. It's real easy. You've never been held to that standard. Now, from here, you can either set both of them equal to 0 or not equal to 0 and solve, but I'm hoping at this stage in the game, you can just look at the two factors, the linear factors, and tell me what the roots of those factors are. What are they? 2 and negative 3 or negative 3 and 2. Perfect. Either way. And you can list them like that. Just make sure you don't say positive 3 and negative 2. Okay? It's the values of x that when you plug in give you 0. So those are the two values that give us division by 0. And that's all we have to worry about in this problem, right? Because there's no radical. So we kind of are standing by the door and we have this list. Don't let 2 in, don't let negative 3 in. Okay, so we're standing there, and if they come along, we kick them out. All right, so those are the only two that aren't allowed. Everything else is. So now all we have to do is state our answer, right, in either interval or set notation. So let's do that. The function's name is f. So remember, as we did yesterday, D for domain, subscript f is the name of the function, colon, not equal. Colon, not equal. And in set notation, we do the open brace, the set of all x, and what does that vertical line mean? Such that, and again, you have some flexibility with set builder notation. You're basically just going to restate that x cannot equal 2, negative 3. Those don't even have to be written in any particular order, least to greatest. You have a lot of flexibility with set builder notation. So that's it. That defines the set perfectly well. And of course, we're assuming that x is what type of number? Imaginary, real, integer? Real. By default, we're dealing with the real numbers. You might have seen something like this, you know, in a book or something. At the end, it says where x is an element of the real numbers. We're not going to do that because we're going to assume it is a real number. And if we want it to be some other group of numbers, that's when we have to specify. Okay, so now all we have to do is write that in interval notation, because I want you to be familiar with both. You can write either one if I don't specify both, but on a test or something, on a multiple choice, I'll use either one. So you need to be comfortable with both. All right, now interval notation, we got to step over the -3 and we got to step over the 2. So remember, interval notation is always left to right, and we have a placeholder. So where should we start? Negative infinity. Good. So we'll put negative infinity. And what goes around negative infinity? Beefy bracket or wimpy parenthesis? Wimpy parenthesis. Okay. Remember, infinity never, ever, 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 ever gets a bracket, nor does negative infinity, because then you're saying that you can get there, and I want to go. So don't do that. And then we cruise all the way to what number on the number line? Very good. Okay. So now in interval notation, they do have to be written in order. Order matters for interval notation. And then we need to step over it. So how do we do that? Parenthesis. What's the symbol we used yesterday? U for union, which means or. Parenthesis -3. That's how we step over it. Okay? And then we cruise all the way up to 2. We step over it. And then once we clear 2, then it's smooth sailing forevermore. There you go. So there it is in interval notation. Yes, ma'am? Okay, let's see. If I put a bracket right here, that means that I'm going to go up to -3 and include -3. A bracket is like an equal sign. Do we want to include -3? No, it causes division by 0. So we put a parenthesis. And because we're dealing with real numbers, there is no first real number to the left of -3. It's not -3.00001, because you can add zeros forever. So that's how we do it. We go right up to -3, step over it, pick up right there on the other side of -3, and keep going. You always step over with parentheses. If you ever put a bracket, you're saying that you're using that value, and we can't. So remember, if the intervals follow D for domain, we're in good shape. But remember, there was something else we could do. Like we did up here, we defined the variable to be x. Remember, in front, if you want, you could put x. You could put the epsilon, which means what? Is an element of, okay? So if you want to do that, that's fine. Again, it's not needed here because it follows the domain. We know their x values. So I typically don't do that. All right, but in Set Builder, it's part of the structure, okay? All right, any comments or questions on that? So good so far, so good? All right. Go ahead and do letter B by yourself. Take, I don't know, a minute and a half. It's very, very similar. But you just have different bad guys on this one. And I'll reiterate the notation, what I would be looking for. So we all have it perfectly already. Yeah.
So why was this not equal? Like, is it always going to be?
Always, right? Because what happens if the denominator is 0? You get division by 0, and that doesn't work. So if we always take...
Do I just put that?
No, we don't even care about the 3x plus 12. That affects the graph, but it doesn't affect the domain. So all I want to see, and you haven't done it yet, so you don't even have an equation. You just have an expression. So use this as a model. What did we do? You'll take x squared minus 16, and you'll say it's not equal to 0. Okay? Yeah. Yeah. All right, cool. No radicals, no fractional exponents. We do have a denominator. There are variables. So here's what I want to see. You're labeling it denom or denominator if you want to write it out. That basically says, here's where I'm doing the work for the denominator. Now, you don't have to write out denom that does not equal 0. What you're doing is you're taking your entire denominator, the whole thing, and you're saying it's not equal to 0. So that's where you would get the check, okay? I wouldn't take off if you didn't write the denominator here. But later on, when we have two different things going on, you're going to want to label it. So start that practice early. Now, to solve this, most of y'all, as I looked around, solved it by factoring. That's great. This is a difference of 2 perfect squares. So remember, if you do that, keep it not equal to 0. Keep it not equal to 0. And now you can just rattle off the two values. X cannot equal what? 4 and minus 4. So the easiest way to do that is to say plus or minus 4. You could do that. You could also solve this one by separating the variables. X squared cannot equal 16. You could do that. And then how do you unsquare something? Square root it. And remember, as we saw yesterday, when you're the one introducing the square root, you have to consider plus or minus. Good. So that's another way to get the two values here. But that's it. Those are the only two that don't work. So now you just write it in the final form. D sub g is the set of all x, such that x is not equal to plus or minus 4. So set builder notation is just a little bit faster, right? It's got a little bit more flexibility. As long as you define the set, get your point across, it's good. Interval notation, it's more like number line work, right? If you're ever in doubt, just do the number line work. Where do we start if it can't be negative 4 or 4? Yeah, negative infinity, okay? And so now it does matter. We have to go to negative 4, step over negative 4, cruise to 4, step over 4, and then cruise to infinity. So none of those end up being brackets, right? So that's what it would look like in interval notation. And notice I did not put x epsilon out front because it follows the domain. All right, any questions on that? We've done two now where we've just had a denominator. We say the entire thing can't equal 0, and we solve, and then we write our answers. Everyone good on that? Okay, good. Well, let's move on to the next one then. Letter C. We got h of x is the square root of 2x minus 3 plus 1. Do we have a denominator? No. Do we have any negative exponents? No. So now we're looking at the other case, right? We have obviously a square root. And so we don't care about the plus 1, just like over here we don't care about the 3x plus 12. For domain purposes, and domain purposes only, we are just interested in the thing under the radical. And what is that called in general? The radicand. Good. So whenever you have a square root, let me spell that correctly, you want to take the radicand, which is the thing under the radical, and now, instead of trying to avoid a single number like 0, we're trying to avoid a whole type of number, right? Negatives. And there are infinitely many negatives. So we frame this one in the positive. Instead of saying which values infinitely many don't work, in the spirit of Rachel's challenge, we're going to keep it positive. We want to find the ones that do work. So you're going to take your radicand, and you're going to say that it is greater than or equal to 0. Okay? So those are your two guidelines right there. Come back over here. If you ever have a denominator, say the whole thing can't equal 0. Find the ones that don't work. And if you ever have a square root or a fourth root, you're going to take the radicand and say it's greater than or equal to 0 and find the ones that do work. So here's what you would write. You don't have to write that, but here's what you would write. I'm going to use rad for radicand, right? It's a cool term. Rad is a cool term, and cool is a rad term, by the way. So 2x minus 3. Notice I did not write the radical, did I? I did not do this is greater than or equal to 0. Some people do that. It's just the thing underneath it. 2x minus 3, okay? So on a quiz or something, that would give you a check for the setup. Now we need to solve that. So how do we solve linear inequalities? Just like an equation? Or was there some rule, some caveat, something to look out for? What was that? There was like something with the inequality, like if you say Beetlejuice 3 times, like flip the problem upside down or something. What was it? Absolutely. That was it. Remember that? So you can't just treat it like a regular equation. You have to remember that if you ever multiply or divide by a negative, you have to flip the inequality around the other way. So let's keep that in mind as we solve this. Okay, so we'll add 3 to both sides, and we get 2x is greater than 3. Pretty easy. And now we're going to divide both sides by what type of 2? A blue 2. A positive 2. Positive 2. Do I need to flip the inequality when I divide by a positive 2? No. Now, I'm going to put an asterisk here because you need to get in the habit of checking, especially for inequalities, because you think anybody ever in the history of math classes has ever forgotten to flip the inequality? Yeah, one guy. One guy did. Okay? So let's check. We are saying that the values that are bigger than 1.5 or 3/2 work. Pick a number quickly bigger than 1.5. 2. 1.6. You try 1.6. I'll try 2. All right? We're going to plug it back up here to see if it works, right? So you plug in 1.6. We'll do yours. 1.6 times 2 is 3.2. 3.2 minus 3.0 is positive. Who cares, right? Close call. I don't care what the number is as long as it's what? Positive or 0. So it works. If you plugged in a 2, you get 4 minus 3 is positive. Who cares? It's 1, I believe. So that means that what? That means that this is the correct interval, right? If you want to try one that you say doesn't work, it's like a double check. What's something that's not bigger than 3/2? 1.4 or 1? We're saying 1 shouldn't work. Plug in a 1 here. 2 times 1 is 2. 2 minus 3 is negative under square root. Ha ha ha. So that means that this is right. This is an indication when you check that you are awesome, right? And who doesn't want that? Bless you. Now, because there's no division by 0, that's the only domain restriction, right? So now we just write it in our formal domain interval or set notation. So that's going to be, let's see, the set of all x such that, and you can just drop that inequality in there like that. You're just kind of prettying up the answer, all right? That would be set notation. What would it be in interval notation? Very good. Beefy bracket, 3/2, comma, what'd you say? To positive infinity with the parentheses. That's it. Good. 3/2 is now a lower bound. It's got to be 3/2 or bigger. So you start at 3/2 with a beefy bracket, comma, infinity. Okay? Either one. All right. So what do we do if we see a square root or a fourth root? We take the what? Radicand and say it is greater than or equal to 0. All right. What about that +1? Ignore it. For now, ignore it. We're only focusing on the domain, not the graph. It's going to affect the graph, but it doesn't affect the domain. All right. Letter P, you do. On your mark, set, giddy up, go. You do. Yes. Hey, don't apologize. What?
If it's a cube root or like a fourth root, do you just go with that first?
Oh, good question. We mentioned this yesterday, and we're only looking at square roots now. This is only for even roots. So if you have a square root, fourth root, sixth root, or something to the 1/2, 1/4, 1/6 power. If it's an odd root, cube root of x, fifth root of x, as we saw yesterday, that doesn't matter. You can have negatives under a cube root. Okay? So if it's just like the cube root of -8, that's -2. So it's only even roots. Only even roots. Yep. If you have a square root? No. For a cube root, then you don't even have to worry about it. It's not a hurdle that we have to overcome. It's just going to be all real numbers, unless there's a denominator. We pay no attention to cube roots in terms of domain, because it's all real numbers. Right now, we're only trying to avoid division by 0 and even roots of negatives. I know that y'all are checking when you get to your inequality before you go all out and formalize it in a pretty notation, right? You're all checking, of course. Good. I'm seeing a lot of the same answers. So math being the democratic subject that it is, that looks like that's going to be the answer. Well done. Look at these two and see if those both say the same thing. Yeah. Right?
I goofed.
Did you?
Did I?
Do these say the same thing?
Yeah.
They do?
Oh.
Because this one says you have to be what? Smaller?
Negative big.
And that one says bigger. Uh-huh. Yeah. That's why I want you to be able to go back and forth between the two notations. Okay, so you walk up to the problem, and it's P of x equals 4 minus 7, right? Hello, 4 minus 7. We're going to break into your house. He's like, okay, I'll look the other way. And we see 3 minus 5x in there, right? That's inside the square root. So here we go. We go rad, and we take the square root of 3 minus 5x, and we say it's greater than or equal to 0, correct? No, we don't do that. We broke into the house. We're not stealing the house. Just the contents, okay? Maybe we'll hook up to it, right? Okay, so this is going to be your setup. Now, we like to have the variables on the left side, so we'll bring the 3 across, and we get that. And then, of course, we divide through by -5, and a negative over a negative is a positive. So we get x is greater than 3/5. But I know that I am a checker. What? I'm getting nervous. Pick a number bigger than 3/5. I claim numbers bigger than 3/5 work. Like 0.7. Pick any number. What's the number bigger than 3/5? 100. Okay, 100. We'll be safe. Let's go big. I'm saying 100 works. 5 times 100 is 500. 3 minus 500 is negative oops, right? Negative oops. And so now I know, oh, yeah, I forgot to flip the inequality. I forgot. I checked myself before I wrecked myself. All right? And, yeah. That's all, right? There's no division by 0. So now we just say d sub p. And now you're thirsty for a Dr. Pepper, such that x is less than or equal to 3/5. Okay? And then we could say, or d sub p is beefy bracket 3/5 to infinity. Yeah? No, I saw that, right? I saw that a few times. These are not saying the same thing. 3/5 is an upper bound, right? Less than 3/5. This says bigger than 3/5. So we have to have 3/5 as an upper bound and then negative infinity. And I wrote it kind of high, so here we go. All right, there we go. Now those say the same thing. Those now say the same thing. Right. If you're ever unsure about interval notation, just think about it as a number line, right? That's all we're doing. So here's 3/5 right here. Because it's less than or equal to, you would put a solid dot because it's equal to, right? And then less than, you would shade to the left. So that's really all interval notation is doing, is it's kind of just interpreting the number line with symbols instead of, sketches. So you could do that first and then write it in interval. All right, so can y'all handle those two things in isolation? Division by 0, denominator can't be 0, solve, find the ones that don't work. Square root, fourth root, radicand, greater than or equal to 0, solve, remember the caveat, find the ones that do work. Yes, Emma? Yes, absolutely. Yes. All right, any other questions? Okay, guess what we're going to do now? Now we're going to put them both together. Oh. Example 5. Find the domain of each of the following. State your answer and set our interval notation. So this guy doesn't have a name. His name is just Y, right? Maybe Yanni? I don't know. Yanni? Laurel. All right, so we take a look at this guy, and we're looking for two things. Are we at risk of dividing by 0 here? Yes, we have variables in the denominator. It's a quadratic, so we need to be looking out for that. Do we also run the risk of taking the square root of a negative? Yes, because I have a radical. So all we're going to do for this problem to find the domain is just do what we've done in the previous example. We're just going to have to do it twice for the same problem. Now, if you are looking for which one to do first, might I recommend the radicand first? Because it generates an inequality, which means it gives you infinitely many values that work and infinitely many values that don't work, whereas the division by 0 is a singularity. Okay, it's just 2 values at most. So let's do the radical work first. 2x minus 1 greater than or equal to 0. There's your check. And notice I did label it as rad because I also am going to have a denom work over here. Okay, so if I solve, we can kind of do this quickly now, but not at the expense of making mistakes. X is greater than a half. Pick a number bigger than a half, like 1. We say 1 should work. Let's try it out. 2 times 1 is 2. 2 minus 1 is positive. Who cares, right? It works. So we know that's the right interval. Now we'll come over here and we'll put denominator. And what do we do with the denominator? We say that what part of it can't equal 0? All of it. We take the entire denominator and we say it can't equal 0. We find the values that don't work. And we solve that just like an equation. So does this one factor? I hope so, right? X minus 5x plus 2. And then I say x cannot equal 5, comma, negative 2. Now look, grade my work right here. If this is what you did yesterday on the quiz, would you get full credit for this work right here? No. I'm looking at some of y'all's, and y'all have not what I have, which is good. What am I missing? I'm missing the not equal 0 on the second line. So, yeah, that matters. Okay, until you solve, there has to be equations all the way down, or in this case, non-equations. So those are the two values. Now, here's the deal. Remember, this guy here has already made his claim. In order to work, you have to be bigger than 1/2. The denominator says I can't be 5 or negative 2. We only need to exclude singularities that give us division by 0 if they happen to fall in the inequality prescribed by the Radicand, right? So to be bigger than 1/2, which one of those do we need to exclude? The 5, right? Because the negative 2 is already excluded by this. But because 5 is bigger than 1/2, I'm going to have to exclude it. So if we combine the two results right here efficiently, we'll say the domain, you could put y there if you want. It's the set of all x such that, and then we'll list the inequality. X has to be bigger than or equal to 1/2, comma, you can do comma, oh, by the way, step over what? 5, okay? That would be like the multiple choice answer. And that's what I want you to shoot for on short answers, free response. Okay, so that's the preferred way to do it. But someone always asks, and you may go ahead and ask, would it be wrong? Would it be wrong if we went ahead and said it can't equal negative 2 either? And what do you think the answer to that is? Is this saying anything? No, x in fact cannot be negative 2. But what you're doing is you're doubly excluding negative 2, right? How is that for negative 2 self-esteem? We're not going to use negative 2. Yeah, we're not going to use negative 2 either. It's like, I was already born negative, and now you're excluding me twice. That's not healthy, right? So I don't want you to do that. There's no need to do that, okay? It's not going to be wrong. I'm not going to count it wrong, but by that same token, if you just like hate some more numbers, like, don't use like negative 11 and negative 555, man, that one irks me. Don't use that one either. You can go on and on and on, right? Those are already excluded by the greater than 1/2. So if this were like a test question and it was multiple choice, I would not have that there, okay? I would only exclude the one that falls in the interval, okay? We do have to step over it. Now, if you're unsure whether to, doubly exclude them or not, do the interval notation. Because the interval notation, you'll see that negative 2 doesn't even come into play. Because by the inequality, you're starting, here's the number line, you're starting at 1/2. It's equal to, and you're shading to the right. Oh, by the way, when you get to 5, don't include it, right? So there would be the number line. Negative 2 is way over here. So as an interval, that would then be bracket 1/2, comma, 5, step over it with parentheses, and cruise to infinity, right? You would actually have to struggle there to try and make negative 2 fit into the interval somehow, all right? I don't even know what that would look like. It would come over here, here's negative 2, and you just put an open circle. Right? I mean, that's what it would look like. But then you can put open circles everywhere. Look, it's bubbly, effervescent, right? Okay? So there you go. Try to be efficient, okay? Don't doubly exclude things. It's bad for their self-esteem. Not very Rachel's challengey of y'all. All right. Any comments or questions on that? We had both situations. We just treated them individually, combined the results. Yes, Mr. Coronado. Yes, please. Again. Yes. Yeah. We're in here till, let's see, 36? Yeah, 36. Okay. Go ahead and do letter B on your own. A little bit different. This one's name is Morris, or M for short, and the independent variable is P, not X. That doesn't really change anything. So go ahead and see if you can't combine the two strategies, division by zero, square roots and negatives, combine results, come up with the domain of Morris, or Morris's domain, to avoid the passive voice. Morris's domain.
My goldfish's name is Morris.
Oh, really? So Morris's domain would be his bowl.
No, he's dead.
Oh. It would be the sewer around him? Did you flush him or did you bury him?
I
Okay. All right. Morris's domain is the Comal County landfill. Yeah. All right. Focus, refocus. We'll agree for Morris some other time. Combine your results. Oh, you're doing 2 and 1.
Yeah.
Solid. Boom, fist bump. That's kind of advanced. I like it. That means you're thinking, and that's really the goal of math education, is to get you to think. So, it's good. If you need help, if you're struggling, just raise your hand, and Mr. Johnson will come over there and help you out. Mm-hmm. And if you're watching the video at home, you're trying it as well. Boring part of the video.
Do we care about the numerator? No.
Not for the domain, right? I mean, you don't want to be rude or anything. You can maybe say hi, 6T. Did you do the division by zero work? Did you do the denominator work? Oh. We can't divide by zero. Do we ever? Are any of those values given you division by zero? All right, I'm going to try and catch up with y'all. If you feel like you're in the groove, just ignore me. I do have a square root, okay? So I'm going to take the radicand, and I'll call it rad, and I'm going to say 4 minus 7t has to be greater than or equal to 0, right? That's what we've been doing. Radicand is greater than or equal to 0. So this is just using the two methods that we talked about. Now, if you think that you're going to be one of those people that always forgets to flip the inequality when you multiply or divide by a negative, and you are heck bent on not checking your answers because you just like to live that way, then you could solve this another way. You could actually get the negative variable to the right side, divide through by 7, and you end up with 4/7 is greater than or equal to t. And now, since we like our variables on the left, just realize that the alligator is eating the 4/7. So when you flip it around, it's still eating the 4/7. So that's another way that you can avoid having to flip the inequality, right? So however you want to do it. I'm going to check, though. Something smaller than 4/7 is 0. I'm saying 0 should work. 4 minus 7 times 0 is 4. That's a positive number, so that's the correct inequality. All right? So now I'm going to do the denominator. Denom. And what part of the denominator do we say can't be 0? All of it. The entire thing. 4 minus 7t with the radical shall not be 0. And now how do we unsquare something on our way to solving? Unsquare root it, sorry. I squared. I gave it away. You square both sides. And you get 4 minus 7t equals, or cannot equal, 0 squared is what? 0, okay? So then we solve, so I'll keep negative 7t on this side. That cannot equal negative 4. And then t then cannot equal positive 4/7. All right, so now all you have to do is combine your results. The Radicand says, I got to be 4/7 or smaller, and the denominator says, I can't be 4/7. Very good. So the most efficient way, d sub m, to remove the 4/7 is just to take away the equal from the inequality. So this will be the set of all. Now you could say x again because you're defining it, but notice the independent variable here is what? T. So it would be better if you said the set of all t such that, and just say t is less than 4, bless you, 7, bless you. Yeah. Okay? So that's the better way to do it. Now, if you notice that in the beginning, if you notice that the entire denominator is the radical, you could do a 2 for 1 here if you see that and just say 4 minus 7t has to be strictly greater than 0. And if you take away the equal sign in the beginning, you're taking into account the division by 0, and you're taking into account the radicand at once, and you'll get your answer. And that's what Caroline did. Maybe some of y'all did that too. I'm fine if you do that. The double method of combining results works great though. Now again, the question always arises. What if we do this, but we're not really thinking, and we write it as the set of all t such that t is less than or equal to 4/7, and comma t is not equal to 4/7. Are you saying anything wrong by saying that? No, you're not, but it's not very efficient. That would be similar to saying, I like peas and I like carrots, but I don't like carrots. And it'd be like, dude, why did you even bring that up then? I don't know. I just like peas and carrots, but not carrots. Okay? It'd be better just to say, I like peas, right? Yeah. Okay. So that's kind of silly to say that. So what would it be in interval notation? Is 4/7 an upper bound or a lower bound? Upper bound, because it's got to be less than. So then it's going to be negative infinity to 4/7 with a wimpy parentheses. There you go. All right, sweet. How y'all doing? Y'all feeling okay? 2 for 1 is not bad, right? It's just doing twice the work and then combining the results efficiently. All right, let's do this last one together and we'll call it a day. I've got variables in the denominator. I got a variable under the square root. So let's do the rad part first. The radicand, negative x, must be greater than or equal to 0. I solve, I flip the inequality, and I get x is less than or equal to negative 0. What the heck is negative 0? It's also 0. Okay, cool. So now let's check. We check. Something smaller than 0 like negative 1. If I plug a negative 1 in for x, what's negative 1 times negative? Positive 1, it works. That's the right interval. Sweet. And now I come over here for the denom, and I say that x squared plus 5, the entire denominator, cannot equal 0. And I solve. So you could solve this one by bringing the 5 across. X squared shall not equal negative 5. Okay. How do we unsquare something? Square root it. And again, second time today, when you take the square root or the eventh root in general, you have to consider plus or minus. And I get the square root of negative 5. Holy moly smokers. What type of number is the square root of negative 5? It's imaginary. So here we're saying then that the only values of x that give us division by 0 are imaginary. We're not dealing with complex numbers. We're dealing with real numbers. So guess which real numbers are allowable? All of them, yeah. So this denominator has no restrictions. There's no domain restrictions from the denominator. So even though you have variables in the denominator, doesn't mean you're going to have division by 0. Okay? It's only possible, not always guaranteed. Now you could spot that right away. Take any number and square it. It's going to be positive or 0 at the very least, and then add 5 to it. Is that ever going to be 0? No, it's going to be 5 at the least. So you don't even have to get this far down. Or if you go one step further, can you ever square a number and get negative? No, so no solution or get no solution here. Now, if you think about the graph of x squared plus 5, that's your old I'm happy to be in a math class, that's why I'm smiling parabola, moved up 5 units. 0's down here. Does it ever equal 0? No, so there's no solution. for that one. So the only restriction is the Radicands restriction. And so the domain of y is just going to be the set of all x such that x is less than or equal to 0. And what would that be in interval notation? Is 0 an upper or a lower bound? Upper bound, okay? So I'll write that first. Does it get a bracket, a beefy bracket, or a wimpy parenthesis? A bracket, because it's equal. And then it's less than that, so negative infinity. So there it is. Okay, there is your answer. Okay, very good. We're going to stop there for today, and we'll quiz tomorrow. So tomorrow, be ready to determine if an equation is a function, yes or no. And then I might give you 3 questions, or I might just give you 2. Finding the domain, I may do a combination thing that requires you to do both anyway. I kind of like that. All right, so just a short 5-minute quiz tomorrow, 2 problems. Be ready to go, grade it, and then we'll get back into the notes. Yeah. I'll give high fives all day long, okay?
How do you find the whole? Is that the same thing?
That's the one that gives you 0 over 0. That's kind of what, we haven't quite talked about that yet. But basically, if you have a factor in the top and bottom, like see these x minus 1s, they divide out. So at x equals 1, we have a whole. There's a y value of a whole there. And then the other one, x minus 5, it doesn't divide out. There's a vertical asymptotic 5. Okay. Yeah. We'll get to that. Yeah. We'll get to that. We're going to talk about holes and vertical asymptotes on example 8. Yeah. Anything that we've done up through today. Yep. Absolutely.
Really like